Good morning, everybody. My name is Kim. I'm the Senior Director of Marketing and Communications. I'm thrilled to be here sitting next to Chris today. We're just going to jump in because we're starting a little bit behind. So we're going to do a brief introduction. Tell us about your role at the Materials Manufacturing Innovation Center and what goes on there.
Thanks, Kim. I'm really happy to be invited to be here today. It's a great day to see everybody. I'm looking forward to meeting as many people as possible. I do lead the Materials Manufacturing Innovation Center at Argonne National Lab. We have no facilities and no scientists. It is me and Marcia, so it's a dynamic duo. Our role is to link the skills and technologies at the lab out to industry and manufacturing companies to support them in whatever they need. So really, I'm a transfer function. I use that term with geeks, so hopefully I can relate to them.
Yes, and we're going to get into that a little bit later, how that happens and that engagement with industry and some of the research that's happening at Argonne. But I wanted to back it up and kind of talk a little bit about your personal career pathways and growth, starting at the very beginning. So I know you have a bachelor's in ceramics and you have a degree in biomedical engineering, eventually got a PhD in glass. Tell us about that and what kind of attracted you to land in material science.
I always liked math and science when I was growing up, and also English. I was one of those kids that people said, what do you want to be? And I was going to be an accountant, I was going to be a synchronized swimmer, I was going to be a senator, I was going to be a lawyer, and you just don't really know. But the good thing about going to a university is you get a chance to explore lots of different things and become a whole person. So not just one aspect of your life, but being a whole person. So we went to some open houses at universities and saw different displays of the technical programs. No shade to chemical engineers, but the chemical engineering display was distillation, and I was not super impressed, but there was a biomedical engineering display that I thought was really interesting. My memory is at that time they weren't taking undergrads, so then I went to a small school in Western New York called Alfred University for ceramic engineering. High temperature materials chemistry is what we call that. And then I went to get a degree in biomedical engineering at Case Western. We did an animal study, and I was like, I can do this, I can do this, I can do this. But we operated on 6 beagles and implanted materials into their femurs, sewed them back up, let them live for 8 weeks, then sacrifice the dog, take out the bones, and see how the materials grew. And I do think that that's valuable work. I just don't want to be the one to do it. So we finished up. Tip number 1, don't name the dogs, not a good idea. And then I went back to grad school I had to get back to the inorganic side of the house and decided to specialize in glass, which is a subset of ceramics.
Thanks for that. I'd love to hear kind of in that early education period or even in your early career, like if you had a moment when you went, oh, like this is exactly what I should be doing, and you felt that excitement for your career choice.
Yeah, I think that's a good question because I wonder how many of us feel it in the moment versus sort of reflecting back. And I was reflecting back about how when you're in middle school and high school, you recreate famous experiments and get the same results. But looking back when I was in college and grad school and we had to do new things and I was building equipment, with wrenches and piping and welding and everything that you have to do to build something novel, that I think was for me, looking backwards, very impactful. I was doing something very new and different, not replicating somebody else's famous experiment. So that, looking backward, that was a kind of a key moment when I was in the lab doing something that nobody had done before.
And you kind of told me a story from your childhood about the toys that you would play with. And I hear that a lot from engineers. They have these early memories of wanting to understand how things worked or seeing certain toys that people are playing with and saying, hey, I want to do that, rather than playing pretend.
Yeah, I was aggravated because my brother kept getting remote-controlled cars for Christmas, and I would not. I was getting stuffed Opus, the penguin from Bloom County. That tells you how old I am. But anyway, he got 2 RC cars, and the first one I was like, wow, that's so cool. Can I play with it? And then he got another one the next year, and I was like, Mom, come on, what's happening here?
That's great. You had reflected on something in an earlier conversation where we were talking about not just that aha moment, but kind of the moments of maybe the highs and lows of of a career and the memories that you hold on to and how those were more oriented around people than things. If you can talk a little bit about that.
Yes, I got hired into a large multinational materials company right out of grad school called Corning Incorporated, and I worked there for more than 20 years before joining the lab a few years ago. And I came in a big wave. Corning was hiring a lot of people at that time, and so there was a big focus on career development for people. Within about 2 years, somebody asked me my best experience and my worst experience at Corning. And I thought about it, and my best experience was helping a technician get promoted to monthly. And my worst experience was this fight with an old engineer that I had where he told me I was one of these women that was going to be climbing the corporate ladder and it didn't matter how many dead bodies I left behind. And I told him he was an old dinosaur that probably ought to retire. So, you can recover from those kind of mistakes is sort of the other point to that story. The first point is that both of those things were people-oriented. They weren't this problem I solved or this problem I couldn't solve. And so I thought, that's very interesting, right? I didn't talk about how I was able to figure out why there was so much dissolved hydrogen in the glass and what that meant for the laser damage properties. They were both people things. So that's when I started to think, maybe I should be thinking about functional technology management. I'd like to help people be successful in their careers. The second point of that is that there are two kinds of people in this world, those that learn from other people's mistakes and the rest of us. And so I hope that by sharing some mistakes that I've made, or things that created me or how I am today, that there'll be something that everybody can take away from that.
And let's talk a little bit more about your time at Corning. So you spent over 25 years there. If you can tell us kind of the different hats that you wore, and then I'd also love your perspective from a manufacturing standpoint, what you saw change in that period of time, either from process or technology tools.
Yeah, I did like working for a materials company. I liked working for a manufacturing company, a company that sells things, not sells their ideas. So that was great. I started as a bench scientist, and then I became a project leader. Then I supervised other scientists, and then I was new business development, launching a product into the marketplace. Can we make something that somebody wants to buy at a price that allows us to make money? Kind of all of those things wrapped up together. That was a very great job. And then I moved into corporate research, which is where the early generation of new ideas, technology initiation. I had been working in development, which in that company was technology deployment. So in the corporate research function, I had visibility to what all of the business units were working on so that I got to learn about semiconductors, mobile emissions after treatment, display, telecommunications, a little bit of pharma, so a nice broad background. And in the research environment, we were working on energy storage, carbon capture, more sustainable things, so that when I came to the lab, I had a really nice kind of level setting. So that's what I did at Corning. The second part of your question? Changed. What
Yes,
technology
yes.
changed, yeah. And when I first started working, I was working in the semiconductor industry on this glass called high purity fused silica, which was still used to make stepper camera lenses to make integrated circuit chips. And the industry was moving from K-line to I-line to 248 nanometer to 193 nanometer, and we were working on the glass for 193 nanometer circuits. And the glass being made in one of our facilities didn't transmit as much light at 193 as a glass made with a different process in another facility, and we were trying to figure that out. And we were doing atomic absorption spectroscopy and trying to figure out, is there some kind of impurity in the glass that's driving this behavior? And the characterization techniques told us that both glasses had less than 10 parts per billion sodium. By the time that I left that business, like 6 years later, the techniques had advanced enough that they could tell us the glass that wasn't transmitting as well had 4 parts per billion sodium, and the glass that was transmitting had 2 parts per billion sodium, and that was making the difference. And the lesson for me was, what was impossible becomes possible. Technologies evolve, tools evolve. I read this book called Physics of the Impossible, and he rates technologies as a type 1, 2, or 3 problem, but in the beginning of each chapter, there's the quote. And one of the quotes was, if an old scientist in a white coat tells you something is possible, he or she is most likely correct. if an old scientist in a white coat tells you something is impossible, he or she is most likely incorrect because things keep evolving. I got a plant tour one time, and they were pulling parts out of the tunnel kiln with a hook. Individual people pulling parts out of a tunnel kiln with a hook. And I said, why aren't you having some robots do that? They said, oh, we tried that in the 80s, but the camera systems didn't work because it's so dark in there. I'm like, well, I'm pretty sure camera technology has evolved a little bit from the 80s. So the things that have changed in technology and in manufacturing is technology and how we manufacture things. And so it is, I think, really interesting around what didn't work and what new things there are, and how do we not be Luddites? How do we not say, well, I tried that 3 years ago, 5 years ago, and it didn't work? Because there is a point where you do want to respect history, but there's also a point where you want to challenge conventional wisdom. And I think that's tricky. I've also seen changes in manufacturing to be more artificial intelligence, more sensors, more closed-loop feedback, and in some cases, less people. So that's always a challenge.
And we can get into some more of that a little bit later on. To kind of cap off your chapter at Corning, you'd mentioned the corporate research role that you had and kind of being responsible for evaluating that next business opportunity. What advice do you have for those big multinational corporations to be more forward-looking and kind of move from this quarter-to-quarter mentality to really understanding what their next big risks and investments should be?
Yeah, there's been so many books written about that, from the Innovator's Dilemma, Clay Christensen and the Innovator's Solution, and Dartmouth and Tuck School teach a lot about box 1, 2, and box 3 thinking, and box 3 thinking is the out there type stuff. But I read this book called Thinking in Bets. I think it's Annie Potts. She's a poker player, and she talked about how in poker, it's partly bluffing and it's a numbers game. Are the odds in your favor to continue to play, or should you fold? And you can know that you've got an 87% chance of winning this hand, and so you play. But if it doesn't work, you shouldn't think that you made the wrong decision, and it shouldn't impact the way that you play the next hand. It just didn't work out in your favor that time. So her advocacy was taking that kind of mentality and applying it to business in terms of, do you have a portfolio of bets? Are you putting some things high risk, high reward, some things low risk, moderate return, but they help smooth out the cyclicality, and bringing that perspective to industry. So we do tend to think about that in different places of, we're making a couple of really big bets, but we also got to kind of keep the wheels on the bus. So it's got to be a balance, just like people's own financial portfolio, what you work on in industry in terms of next product. Also thinking about, do you have a balanced portfolio is helpful.
And then bringing it back to Argonne, I know, a ethos of the organization is, de-risking early stage technology for industry, and especially in your role, if you can kind of talk about that transfer from lab to industry. That's something that mHUB, is the recipient of multiple DOE awards, also practices through our accelerator and the programs that we host for early stage technology in partnership with industry. So I'd love to hear about Argonne's approach for making that connection.
Thanks, Kim. The Department of Energy wants the labs, the 17 national labs operated for the benefit of the Department of Energy across the country. We've got 2 in Illinois, by the way, Argonne and Fermilab. The Department of Energy wants us to deliver technology and innovations for the benefit. So we don't invent and to have it sit on the shelf. We don't invent to get intellectual property that we hoard so that other people can't use it. The whole purpose is to transfer it out. And so we do that in a variety of mechanisms. Probably the most oft used is a cooperative research and development agreement, a CRADA. And in that comes inherent kind of technology transfer terms. When we're working together with a company and we figure out some kind of problem together, then they have rights to use it. We can also, there are times when we have invented something kind of on our own without a collaborator, in which case then we do want to kind of share that with people and see if we can tailor it to their solution, and then they would get rights to the intellectual property that way. And then we also have a lab-embedded entrepreneur program, and we work closely with entrepreneurs, and they leverage mHUB heavily, the chain reaction innovations activity. So that's a nice collaboration that we have, and that's another mechanism for getting IP and technology transferred. The Department of Energy, they have funding opportunity announcements. So somebody at the DOE says, I wonder if we could make a cathode material that's got 20% better capacity but costs 50% less. And so they'll put out a call for funding saying, anybody that has an idea on how you could do this, please write a proposal, and if I like your proposal, I'll fund it. And they require some kind of cost share from a company. So a lab can't just do something that they think on their own is interesting. If a company isn't willing to put a little skin in the game with some kind of cost share, then it must not be a great idea. So the Department of Energy is using the willingness of companies to kind of co-invest in technology as a metric for, is this a good use of the federal government's money?
That's great. And I know IP ownership must be a huge consideration there. In terms of that willingness, like what are there other hesitancies or pain points that you see from industry when approaching them for these collaborations that you guys always find yourself addressing?
The federal bureaucracy is a big battleship. The national labs are big bureaucracies, and they don't move super fast. And entrepreneurs and small companies are need to be speedy, right? You have to be working quickly at things. So there can be what we call an impedance mismatch between small companies and this large behemoth organization in terms of getting things approved. So that's one. The other one is the labs can be perceived to be very high cost. But we maintain world-class facilities that nobody else could afford to maintain, like the advanced photon source for characterization, and like the supercomputers in the Advanced Leadership Computing Facility. We have the Materials Engineering Research Facility that's used to scale up. We have the Center for Nanomaterials, which is a bunch of clean rooms, semiconductor processing, and characterization techniques. And because of these advanced, specialized user facilities that anybody could use, that does require some overhead. And so the lab can be perceived to be really expensive. That's another barrier. So there's the slowness. And then the Department of Energy has embedded in contracts kind of IP step-in terms, where if a company takes IP but then doesn't use it, the Department of Energy can kind of step in. But what I've heard is that no one has ever in their X number of years working at a national lab seen the Department of Energy do that, but they still kind of retain that right. And so some companies balk at that requirement.
Thank you. So you kind of talked a little bit about the excellent labs there. Let's talk about the technology that you're seeing right now, kind of in the terms of, as we're talking about career pathways and, there's the clean tech economy, the green economy. What are you seeing? What technology are you seeing developed maybe in an early or, more developed stage that you think is going to create new career opportunities in the next 5, 10, 20 years?
Yeah, so at the Materials Manufacturing Innovation Center, we're working to connect with materials companies. And I think that some people think that means only top line. What is the next material? What's the next product? But it also can mean supply chain and raw materials. It can mean workforce. It can mean process decarbonization, efficiency, yield, straight line manufacturing, value stream mapping. It can mean shipping, transportation, and logistics, as well as top line, what is the new material? So we work across the lab. The lab has skills and technologies in all of those spaces. For process decarbonization, electrification, how do you use hydrogen instead of natural gas? How do you integrate electricity from renewable sources into your process and guarantee that your process won't go down? Is there something that we should be doing in long duration energy storage, which is more than, say, 24 hours worth of energy to make sure that your process can stay up and running? There's the hydrogen economy, which is coming, so we have a lot of work on using hydrogen as a process gas instead of, say, methane as a process gas. transporting hydrogen, generating hydrogen. The lab has, we've got a lot of work in carbon capture. So whether that's direct air capture or point source capture, and then carbon utilization, can you turn CO2 into methanol, something like that, or maybe a carbonate, some kind of other product, which can also work as a sequester. Critical materials, so our country is a little low on refining of critical materials. We have pretty good mining, but we buy a lot of refined rare earth materials that are used in magnets and high technology devices. And if we could develop domestic sources for these critical materials, that'll be really important. That can be membranes and separations. Let me see. There's microelectronics and power electronics. So can we transfer thermal energy and electrical energy more efficiently compared to the current materials, which are kind of copper-based or aluminum-based? So there's a wide spectrum of technologies that we're working on to help materials companies. And so for the future, I mean, people talk about quantum. That'll certainly be there eventually. And then the other novel technology that I'm really interested in is dynamic catalysts. So these are materials, we all know catalysts kind of help a reaction move along a little faster. And dynamic catalysts change their behavior as a function of the reaction that's happening, which is sort of like artificial intelligence, which changes the algorithm in response to external stimulus. And so a dynamic catalyst, I think it's going to be really interesting in terms of plastic upcycling. So taking plastic waste and upcycling it to something more useful, that will be another technology area that I think is going to be ripe for manufacturing.
Well, that's a lot of exciting stuff for this room to consider. You had said something in a prior interview about viewing technology not just for the ability to advance and solve problems like you just exhibited, but also as a way to create jobs. Can you tell us about that point of view?
I hope that's not a unique point of view, honestly, because I think that part of that role that I had when I was working at Corning in the new product deployment was, if there's a new product that we can be making, then we need to be hiring people. We need to build a plant maybe, or at least brownfield something, and get some new jobs. So new technology equals new jobs. I was looking online for some statistics. 11% of the U.S. GDP is from manufacturing, and 8.5% of the working population is working in manufacturing. And it said more than 95% of companies are considered small and medium manufacturers, and like 70% of companies have less than 20 people. And so I'm kind of curious, how many people work for a company that has less than 20 employees? Yes, that's maybe 15% in the room or something like that, 10% in the room. That's interesting to me. But I do think that new technology it means new jobs. New skills need to be created, new products need to be made, new advances mean more jobs for more people. So investing in technology, I think, is an investment in manufacturing.
And in talking about job creation, I know some manufacturers right now are feeling the pain of open roles and how to kind of ready their workforce for this new technology that's coming. What do you think, from your perspective, manufacturers could be doing to ready their workforce and also attract more young people into the field?
That's a super interesting topic. We spend a fair amount of time on workforce development. The lab has what I had heard recently as a K to Gray kind of program, series of programming. So, but I saw it written as K to career. And so we do a lot of work with the STEM pipeline and getting into schools, into middle schools and high schools and college and grad schools, and getting people onto the lab. So we run summer camps for students. They can learn to code, do Lego robotics, things like that. We have a lot of interns. This year we had more than 1,000 interns. So the lab does a surprising amount in workforce development. But workforce for manufacturing, there's a significant number of programs that each state runs. So I just led a little project trying to figure out what are the workforce programs in Indiana, Ohio, and Michigan. And you can nose around those websites for a long time, and it takes a while to figure out where are all the the programs for to upskill workforce. They're out there, but you have to work really hard at it. The Manufacturing USA institutes that are run by Department of Commerce, Department of Energy, Department of Defense, also have workforce activities, and so you have to go into each one of those Manufacturing USA websites to figure out what workforce programs they have. Trade groups also have workforce programs for their membership. So there's plenty of opportunities out there, but the hard part is when you're a small company and you're working really hard, how do you find the time to find the programs to help your people? I think that's a tricky thing. I've seen manufacturers do summer interns for manufacturing. I heard that there's a program, I think it's in Ohio, where they're reaching out, an organization, maybe it's the state, is reaching out to mothers, because a lot of kids talk to their parents, mostly their mothers, about what it is that they should do when they grow up. And so the idea was mothers don't know that manufacturing can be a great career. So how does the state talk to mothers about manufacturing being a good career for their children? That's a really interesting thing. There's a company in Northern Illinois called Scott Forge. They have like a signing day. So they'll go out to the high schools and recruit. And then when the student in high school says, yeah, I'll come to work at Scott Forge, they bring them in and they have like a signing day, like a sports thing, and they give them t-shirts, and have the family come in and make it like this really big deal. But you have to do those sorts of proactive kind of recruiting things these days, it feels like.
Yeah. Is Sarah Hartwick in the room? So hi, Sarah. She's going to be moderating our next panel, so I'm going to let you share a little bit more in that context. But the state of Illinois just launched a big marketing campaign called Make It in Illinois, so you guys should all check it out. But it does a bit of that where it aggregates apprenticeship programs and training programs at community colleges. So I'm personally really excited to see where that goes for the state. Okay, so believe it or not, we're getting to the end. I have time for one more question. If you can give some career advice to the young professionals in the room about getting started in engineering, manufacturing, or even the sciences, what are one or two big takeaways from your career that you would tell people just getting started? Thanks.
I often tell people that if you care and if you try hard, you'll probably be okay. Because if you care, you're going to be working for continuous improvement. This didn't work, I'm going to try something new. If you try hard, it's about experimentation. This didn't work, I'm going to try something new. So it's okay to have a bad experience. It's not okay to let that bad experience prevent you from moving forward. So if you can look at it as like an experiment, okay, well that didn't work, now I'm going to have to try something else, then I think that you'll continue to grow and advance. I often say that I've been fairly successful because I'm willing to be the adult in the room, which is I'm willing to do the thing I know has to get done, but I really don't want to do it. Whether that's having a conflict with somebody or confronting somebody or sitting down and doing the hard work, if I can be the adult in the room and move things forward, then that always helps. Building a network is really important. I think that some people think networking is all about how do I get my next job, but it's not. A network is an ability to solve a problem, any kind of a problem. It can be, I don't know where to go to get this measurement made. I don't know where I can get this raw material. I don't know the safety impact of this material. So you just leverage your network and ask for help. It can be, I don't know where to send my kid to summer school. It could be, I need some career advice. It could be any of these things. So building out a network is really important. And everybody kind of knows that, but the tactical part can be really difficult. I do like this reference called networking for nerds, because it's sometimes difficult for technical people to be a little bit more extroverted. It's perceived to be extroverted. So if you feel like you're an introverted person, how do you just walk up to somebody and say hi and start a conversation? When you're gonna try to meet somebody new, I recommend that you bring something to share. I ran across this piece of information and I wanted to share it. Here's a cool result that came from the lab or came from the manufacturing line, or here's a problem I'm having, I wanted to get your ideas. Something to get a kind of a conversation going. And then you can ask them what their best career experience was, what their worst career experience is. You can ask them for their advice. So being very tactical and planned around interactions with people as a way to build a network, and then maintaining it. Lunch or coffee or email, or I saw this article and it made me think of you. Anything to kind of maintain contact so that 2 years down the line, when you're like, who do I know that XYZ, and you figure out who it is, it's not the first time that they've heard from you and like, oh great, Chris is calling me because she needs something. You know, you're building the network and maintaining it over time. So those are kind of key pieces of advice that I usually give to people.
Well, excellent advice that perhaps some of us can put into practice today. So Chris, this time has gone by so quickly. I know we could dig into so much more with you. If everyone can join me in thanking Chris for being here and giving us her time.